Binary multiplication. The table shows the rules for binary multiplication. For 0 into 0, the product is 0. For 0 into 1, it is 0. For 1 into 0, it is 0. And for 1 into 1, it is 1. So from this you can understand, for if any number is multiplied with 0, you get the answer as 0. Problem 1. Binary multiplication is done in the same way as decimal multiplication. Here, this number represents the multiplicand and this number is the multiplier. So first, let's start with the least significant bit of the multiplier and proceed a multiplication. First, let's take this 1 and multiply 1 with this 1. So you get the answer 1. Next, again take this 1 and multiply with 0. So the answer is 0. Then 1 into 1 will give 1. And 1 into this 1 will give you 1. Next, let's take this number 0 and multiply with each of the bits in the multiplicand. So 0 into 1 will give 0. Anything you multiply with 0, the answer will be 0. So when you multiply 0 with each of the bits, the answer will be 0. So let's start writing from this position. From the second position, we will start writing the answer. So 0 into 1 will be 0. Then 0 into 0 is 0. 0 into 1 is 0. 0 into 1 again 1 is 0. So when you multiply this with each of this, the answer is 0. Next, take this 1 and multiply it with each of the bits in the multiplicand. So 1 into 1 gives 1. So we will start writing from the third position here. Next, 1 into 0 gives 0. Then 1 into 1 is 1. Then again 1 into 1 is 1. So now we have to do binary addition, and a binary addition is done in column wise. So let's proceed with it. So first assume here you have 0. Let's put 0 here. So now let's do the addition. 1 plus 0 will give you 1. Next, 0 plus 0 plus 0, the answer is 0. 1 plus 0 plus 1, the sum will be 0 and the carry will be 1. So sum is 0 and the carry is 1. Again 1 plus 1. So the sum will be 0 and the carry will be 1. Again 1 plus 1. So the sum will be 0 and the carry will be 1. So add 1 plus 1. So the answer will be, the sum will be 0 and carry will be 1. 0 and the carry will be 1. So the carry also you can write it here. So 1. So this is the answer. Let's verify what we have done is correct by converting this into an equivalent decimal number and multiply and see whether we get the correct answer. So for this multiplicand, the equivalent decimal is 13, and for this multiplier, the equivalent decimal number is 5. So when we multiply the decimal 13 with decimal 5, you get the answer 65. So this is all base 10. So let's check. We have the weight of each of the column. We have the weights. So for this, the weight is 2 power 6, that is 64. 2 power 6 is 64, so you have 1 here, so 2 power 6, so all others are 0, then here 1, so 2 power 0, that is 2 power 0 is 1, so 64, so 64 plus for this 1, it is 1, because 2 power 0 is 1. So that is equal to 65. So your answer is correct. Problem 2. In this number, this is the multiplicand and this is the multiplier. And these numbers have both the integer part and the fractional part. So to proceed with the multiplication, first let us remove these binary point, and we can proceed the multiplication. So at the end, at the final answer, we can insert the binary point. Let's start with the least significant bit of the multiplier. Now let us multiply this with each of the digits in the multiplicand. So 1 into 1 gives 1, and 1 into 0 gives 0, and 1 into 1 gives 1, and 1 into 1 gives 1, and 1 into 0, 0, 1 into 1, 1. Next, let us take the next bit and proceed. So 0 into 1 gives 0. So when we multiply 0 with any of the number, we will get the answer 0. So first 0 into 1 gives 0, and we should start writing it from the second position. So 0 into 1 is 0. So all the numbers will be 0 here. Okay, next let's take this bit and multiply with each of the digits in the multiplicand. So the answer will be, so 1 into 1 will be 1, and we'll start it writing from the third position here. So 1 into 1 is 1, 1 into 0 is 0, then 1 into 1 is 1, again 1 into 1 is 1, 1 into 0 is 0, 1 into 1 is 1. Next let us take the next bit and proceed in the same way, and the answer will be 1 into, so we'll start it from the fourth position. So 1 into 1 is 1, then 1 into 0 is 0, then 1 into 1, 1, 1 into 1 is 1, 1 into 0 is 0, again 1 into 1 is 1. Next step is we have to add these column wise. Assume you have 0 here. Okay, now do the addition. So when you add 1 in this column, the answer will be 1. So you can also refer this table, addition table, binary addition table. Next column, this one is, the answer is 0. Next column, 1 plus 1. So the sum will be, so 1 plus 1, the sum will be 0 and carry is 1. So sum is 0 and the carry is 1. Now 1 plus 1 plus 1. So 3 ones you are adding. So 3 ones when we add, sum is 1 and carry is also 1. So sum is 1 and the carry is also 1. Now 1 plus 1. So sum is 0 and carry is 1. Now 1 plus 1 plus 1 plus 1. That is 4 ones you are adding. When we add 4 ones, the sum is 0 and the carry is 1 0. So sum is 0 and the carry is 1 0. So next is, when we add 1 0 plus 1, you will get that the meaning is you are adding 3 ones. That is 1 0 plus 1 is 1 1. So the sum will be 1 and the carry is also 1. So sum is 1 and carry is also 1. Next, 1 plus 1, sum is 0 and the carry is 1. Again 1 plus 1, sum is 0 and the carry will be 1. So here no need to carry anything, so you can write answer here. So 1. So this is the answer. So now let us verify this with the decimal multiplication. Before that, let's put the binary point. So here the binary point comes here. For this it is here. So meaning is, here you have, in the fraction part there are 2 bits, and in here in the fraction part there are 2 bits. Here in the fraction part there is only 1 bit. So altogether 3. So you have to, in the result, in the answer, you have to, the fraction part should have 3 bits. So there should be 3 bits in the fraction part. So you can keep the point here. So in the fraction part there is 3 bits. So now let us verify, check it with the decimal multiplication. The decimal equivalent of this number, before that, okay, equivalent of this number is 11.25, and the decimal equivalent of this number is 6.5. So when we these are decimal numbers base 10. When we multiply this, we get the answer 73.125. This is the base 10 decimal number. So this should be equal to this, this answer should be equivalent to this decimal number. So let's find. So the weights are here. So here in this 2 power 6 there is a 1. So 2 power 6 is 64. So here this is 64. Next, the 1 is present here in 2 power 3, that is 8. Next, 1 is present in 2 power 0, that is 1. then 1 is present in 2 power minus 3, since this is a fraction part, minus 3. So 2 power minus 3 is 0.125. So when you add this 64 plus 8 plus 1 plus 0.125, when you add, you get the answer 73.125. So the answer is correct. Both are equal, so the answer is correct.